Hare Krishna. Welcome back to my channel. I hope you are all doing great. This is LeetCode medium level problem. Find first and last position of an element in a sorted array. So basically we will be given one sorted array. So those are actually in ascending order. Let me take an example here. So if our input is of something like this, 2, 2, 3, 3. Let's assume this is our input. So we need to return the first and last occurrence of x. So x will be given in our input target, we can say that as. And let's assume if our target is of 3. So what is the first occurrence? It occurred at index 2, starts from 0, 1, 2, and then 3, 4, 5, 6, 7. So it occurred again at 7. So we need to return 2 comma 7. And if there is no occurrence, then we need to return minus 1 minus 1. That's all the problem statement. We'll try to see how we can solve this problem. If we carefully observe, what is the naive approach can be. So the naive approach can be you can iterate through this array once, big of n times, I mean to say. Then what you can see is you can take two variable, maybe first occurrence and second occurrence. So whenever you encountered x that is equal to this value, then you first initial it to first, and then you keep on moving, and whenever you encountered this one, and then you assign that to the second, here 2 comma 7, and then you can return 2 comma 7. So here it's kind of linear search you are doing, linear search, where the time complexity is big of n, space complexity is big of 1, because we are not taking any additional data structure to store this all something, just we are taking some constant variables. So this looks good, but we can take the leverage, I mean advantage of binary search in this problem. That is actually the goal behind this problem. So we can see this is already sorted array, right? So when there is a sorted array, okay, whether it may be ascending or descending, try to think about binary search. Try to think whether you can apply binary search there. Okay, most of the cases we can apply, but now let's see in this problem also. Okay, now what we can do here is, and in the problem statement also, they're also expecting us to come up with a big of log n. Okay, this also gives us one hint to use binary search algorithm. Okay, let me take this same input array 2 comma 2 comma 3 3 3 3 3 3 and then 7 9 12. Let's assume. So what we are going to do here is we are going to have some answer with a constant variable. Okay. Basically, this is our start. I'm denoting it as S, and then end. Okay, start plus end divided by 2. So what are the indices? Okay, let me make a note of those. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what is our mid going to be? Okay, 0 plus 10 divided by 2, that is nothing but 5. So your mid lies here now. So now you need to keep in mind there are two possibilities. Either this can be your start index of the x. So by the way, x equal to 3, that is not the target. So there are two possibilities for us. Either this can be a start of the first occurrence, okay, or else your first occurrence can be in this, right? It cannot be in this container, right? So it can be only in this. The reason is like if this is the start, then it's fine. If this is not set, then it will be in left side only, not in the right side. So now we need to look in this part to find the first occurrence. First occurrence. And once we've done that, okay, now it's time for look at second occurrence. So second occurrence can be in this part only, right? To the right side of this three. It cannot be inside this. So this is to find second occurrence. So basically what we are going to do here is we are going to run binary search two times, okay, to find the first occurrence, to find the second occurrence separately. Okay, now let's quickly see what we are going to do. Let's assume we are trying to find the first occurrence. So we found m equals to, which is equals to 3, that is our target. So there may be a potential, okay, potential reason for this is maybe the start index of the 3. Okay, so for that we store this into the answer. Okay, is equals to 5 index. Now we need to find first occurrence, right? Then we come to this part. So what we do? End equal to mid minus 1. Then what will happen? My end will come to this location. My end will come to this location. Now what I am going to do here? Same start plus end divided by 2. So what is start? Start still 0. What is end at 4 divided by 2? That is nothing but 2. Now my mid is at this position. Okay. Now this is 3 is equal to target. Then I update my answer to this index 2 because now this is the first occurrence. When I say first occurrence, this is occurred prior to the last index, right? Because the last index is 5, now this index is 2. So this occurred prior to the last one. Now there might be a chance still maybe from here 3 is getting started. We never know, right? So still we need to come back. Sorry, we need to look at the left side. Then what I'm going to do? I'm going to update my end to point this. Okay, now what happens? 0 plus 1 divided by 2, that is nothing but 1 divided by 2, that is nothing but 0. Then what happens? Your mid comes to here. Okay, this is 2. Now you can observe it. Now you can observe it. 2 is less than x. That means 3 lies in this direction, right? And we already covered the direction. So now what happens? You increment this mid, right? Because 2 is less than 3. Now what happens? S is equals to mid plus 1. What is mid? 0. 0 plus 1, that is nothing but 1. Okay. Now it will be at here. S. Okay, now S and E both start and end are pointing to the same location, and 1 plus 1, 2 divided by 2, that is nothing but again 1. So basically, now mid also points to this location. Now you see still this is also less. Then you move your S to this location. Okay. Now here violating. So your end is pointing to index 1, your start is pointing to index 2. So this violates our while condition. Then you come out of the loop. Okay. Once you come out of loop, you need to return whatever you hold here in the answer. That indicates the your first occurrence of the X. I hope you are able to follow me. So this is how all about the first occurrence, and you do same work for here also, okay, to find the second occurrence, and then you return both first comma second. Okay. Uh, let's see what is the time and space complex. So the time complexity is going to big O of log n of to find first occurrence, then big O of log n, then it is nothing but again big O of log n only. Okay. So that's good. And the space complexity is going to be big of 1 because we are doing in the constant space only. Okay. And this is truly good approach. The reason binary search always divides if your input size is of n, then it divides by 2 and then further 2 and then further 2. So in a 1 million rows, 1 million numbers, okay, if you would like to if you would like to find the first and the last occurrence of a number, okay, and linear search in worst case it needs to do 1 million comparison, whereas binary search hardly do 20 comparisons. Okay, that is the reason this question focused only on logarithmic time complexity. Okay, I hope you followed me. Let's quickly take my last submitted code, take my last submitted. So you see here, so initially I took minus one as a result because I know I need to return the array size of 2, where first indicates the occurrence of first index and second index. So I wrote two methods: find first position where I pass nums target, and second find last position. So if there is no first occurrence, okay, then your answer is ultimately going to be minus one. Okay, you are not going to have a valid reason because it's going to appear only once. Okay, then this is some edge case, some not a edge case, like some condition check to avoid performing the last search operation. Okay, and then at the end I'm doing result. Now let's see, find first what it is doing. So initially -1, then start less than n, mid. So if mid equal to this same, okay, target, then what I'm going to do here is I'm going to update answer equal to mid wherever I am. So since this is the first, I know I need to look at the left side, right? So that's the reason I'm saying end equal to mid -1. Okay, and if mid value is less than my target, let's assume my target is 3 but my mid is 2, what I need to do, I need to go to the right side, right? So that's the reason like start equal to mid plus 1. In other case, like it is going to be mid minus 1. Okay, so at the end, like I'm going to have the answer which holds the first occurrence of my number, and same applicable to the last position. The only difference is if I found the mid, then I know for sure I need to look in the sorry, right side to find the last position. For that reason, like I'm saying like start equal to mid plus 1. Okay, here end equal to mid minus 1. So this is for looking at the left side portion. This statement is to look for the right side position, right side portion, I mean to say. So then the same condition, like if mid is less than target, start plus 1, end minus 1. This is a typical binary search conditions. Okay, and then at the end I'm going to return answer. Okay, and then it's going to return the answer. Let's submit it quickly. So it got submitted like 0 milliseconds. Seems good. So one small suggestion for you. So I wrote these two functions separately. Okay, but if you observe the two functions, 95% code is same. The only statement which differs is like determining to go left or right. Only this. So what I suggest you is instead of writing these two functions, right, you can write only single function like find position. Okay, maybe do not restrict to the first or last. Find position and pass one target here. Let's assume like Boolean uh, is first. Okay, which tells okay, are you trying to find the first position or else last position? If it is first, right? So make this a conditional. Like if is first true, then do this, else this. So in that case, like you can completely ignore this one. Maybe so. I hope you learned something new today. Finally, Hari bol.